So a basis in linear vector space consists of a set of vectors, linearly independent vectors called basis vectors, and any other vector which belongs to this vector space can be written as the linear combination of these basis vectors. So in this question, these basis vectors are 1, 0, 0, 0, 1, 0, and 0, 0, 1. And you need to find this transformation matrix T. And then you have to also calculate the inverse of this matrix. So let us assume that this column vector is represented by X equal to A, B, C. And since the basis vectors, we can expand any vector as a linear combination of the vector space basis vectors. So we can just 0, 1, 0. We can write this left hand side as this also. Okay, which is nothing but A times E1 plus B times E2. We can write this, right? It's just that we can write this A times E1 vectors, so that is 1, 0, 0 plus B times 0, 0, 1. You will just apply this, you will just get this A, B, C. You will just get this column vector. Now, you operate some linear transformation on this vector space, Tx. So X is this. So on equation X, just operate T. So what you get is A is some constant, so this come out. Not constant, but you can just operate T on this. You can operate T on this basis vectors. So you can also write this as T A B C is nothing but AT. E1 is your 1, 0, 0 plus 0, 1, 0 plus C times 0, 0, 1. Okay. And now you'll just, this is equation 3. Now just equation 1. Let us use this property. T of A, B, C is nothing but A plus B, B plus C, C plus A. So similarly, we can write T of 1, 0, 0 is nothing but A plus B, A. Suppose this is A, this is B, this is C. So A plus B, so it is 1. B plus C is 0. And C plus A is 1. Similarly, second will become A plus B is 1. B plus C is 1. And C plus A is 0. Plus C times A plus B is 0. B plus C is 1. And C plus A is 1. So T of A, B, C can be written as this. And when we combine this, so what we'll get is you can write this as this form: 1, 1, 0, 0, 1, 1, 1, 0, 1, A, B, C. So your transformation matrix is nothing but this 1, 1, 0. You're just using, I just combine this. You can just take this as 1 and you can just write this in this form. So this represents your transformation matrix 1, 1, 0, 0, 1, 1, 1, 0, 1. And now they have been asked to find the T inverse. So T inverse is nothing but you just find adjoint times determinant of A. Sorry, not A, this T. So adjoint of T is nothing but, I hope many of you must be knowing how to find this. So you just for example, this is 1, 2, 1, 2, 1, 3, 2, 1. I'm writing the indices of that. This represents first row, first column. This represents first row, second column, first row, third column, similarly. So just take the sum of these indices, 2, 1 plus 1, 2, and they find the cofactor. We'll just ignore first column and first row and find the cofactor, which is 1, 1, 0, 1. Similarly, you will just take the second element, which is this one. Sorry. So what you'll get is minus 1 to the power 1 plus 2, 3. Cofactor will be 0, 1, 1, 1. And similarly, minus 1 to the power 4. Cofactor will be 0, 1, 1, 0. You all must be knowing how to calculate adjoint, right? Do I need to solve it, or you know how to calculate?
So we know.
You know, right? So you just
Yeah.
find the adjoint and you just take a transpose. So what you'll finally get is this T inverse is nothing but some 2 is the determinant of this matrix, and 1, it will come out to be something as 1 minus 1, 1, 1, 1. You can just solve this on your own and verify this is the answer. So this is basically this T represents linear transformation matrix, which when acts on ABC produces this kind of transformation. So yeah, this is a kind of question which comes, it rarely comes, but it is important to understand linear vector space. So uh, this is what I will have to cover in today's class. Because I also wanted to next class in the gate portal, I think it's written differential equation. But what I will do is that since we have many classes, so I will continue this linear vector space in the next class also. So I will in the next class I will be talking about the linear independence of vectors in detail, and I will solve questions also. And last session I solved most of the questions, but I think since many of you are new, you joined new, so I will cover those questions again if needed, so that it's easy for you to understand. So in the next class, I will be talking about linear independence of vectors and other questions related to that. And then next to next week, then I will come to differential equations, special functions. Those. Vinayak is saying, would be when you share the PPT. Yeah, I will be sharing the PPT. You just type your email in the chat box. All of you who want to have those access to those PPTs of previous session.
Sir,
Hello,
hello, sir. Can you show the last slide?
last slide. Hmm. Who is like? So some of you are joining now. It's too late. Like I think this first class. So the timing for this session is 3 to 4 p.m. every Saturday, 3 to 4 p.m. You can join in time so that like it doesn't like so that you'll be able to get everything. Someone is asking, have you joined through Gate? Yes, yes. Like, okay, yeah, this kind of informal discussion is we can also have like, how can like yeah, I joined the IC to GATE exam only. Like, my background is MSc in physics from Delhi University, and then I gave GATE exam, and then I got a call letter from IC. Thank you, Amit. So yeah, so your GATE exam is in February, right?
Yes, sir.
So date have come. Dates. When is it? Date? Still
4, 5 or 11, 12.
okay, okay. So most probably I will be the classes will go on till I think January 2020, like 3 weeks of January. So so I think many of Rajiv, I already have your email ID. You were there in last session. So just wanted to know that most of you are like are you MSc students or like you are from physics, right? Everyone. So
Yes, sir.
MSc physics, new students also. Someone from BTech also. Okay. Mm-hmm. To the different parts of country, people are joining. Oh, summaries of PhD. Uh, okay, fine. Okay, so I just hope, and I just you can also provide feedbacks like what you want to focus on. Like I will cover a few things. Then in the later part of the lectures, like when we have 3-4 weeks left, based on a feedback, I will cover topic. Like in last session, also I did the same thing. Based on the feedback, I covered some special topics. So in this session also, if you have some doubt, most of you have some doubt related to some topic, we'll cover that. Okay, so I think we can close today's session, and we'll meet next week on Saturday. Thank you.